All right, welcome to the 26th Google Cloud Platform online meetup. Thank you for joining us today. We always appreciate you taking the time to make these things great. So my name is Anthony Bouchon, and I'm one of the multiple hosts in the Google Cloud Platform online meetup, and I'm also a customer engineer here at Google. And today, I am fortunate to be joined by the famous or infamous Gus Class. Gus Class here is an IoT wizard, and I kid you not, that is his actual title here. And he's joining us from Seattle. So Gus, you want to introduce yourself?
Yeah, thanks a lot for the warm introduction, Anthony. It was great chatting with you earlier. And so my name is Gus Class. I'm a developer programs engineer at Google. I've worked here for about 5 years, and I have a history of working on identity products and IoT products. So today I'm going to be talking about Google Cloud IoT Core, which is a way of connecting constrained devices to Google Cloud services. And a word of warning, this is a technical deep dive, which means that I'm going to be covering a whole lot of material in a short period of time, starting at the architecture level and then going all the way down to the product level and demonstrating the product. So bear with me as we move along. Again, as a side effect, there's a lot of information that I'm going to have to be covering, and there's also a lot of background that I'm going to have to start with. So don't feel like you need to transcribe everything down. Don't feel like you need to take pictures of this. The slides will be made available to you afterwards, so you can follow along more closely. And also the event will be streamed and recorded. So relax while you watch. And yeah, and so it's just take down a few notes, that maybe a few takeaways that are interesting for you, and don't feel like you have to understand everything that I'm talking about, because this is going to be covering a lot of material.
Yeah, and one of the things too, Gus, is with the GCP online meetup, we do have a live chat here, so we'll try to facilitate some questions as you guide us through the very complex concepts that we'll be covering today. So I'll make sure to inject questions so that we ensure the audience is with us. But I trust that they will be, because you are guiding us. So we're excited.
All right. Okay, yeah, thanks a bunch, Anthony. And yeah, so if questions come up, or if we need to slow down a bit as I'm moving through things, I'm happy to stop and pause and give additional context to what I'm talking about. All right, so let's start with a background on Google Cloud, on IoT and Google Cloud Platform. So what is IoT? If you watched a talk about 10 years ago about IoT, the talk probably began with something along the lines of, pretty soon, there's going to be more devices connected to the internet than there are people connected to the internet. And people kind of parroted this thought for a while. And the reality is that we've long since passed that event horizon. There are far more connected devices on the internet than there are people, and that's been true for the better part of a decade. And additionally, there's a new trend that's actually happening, and the number of devices that are connected to the internet is beginning to surpass the number of devices that don't have connectivity. So what is IoT? IoT is taking devices that would be conventionally not connected to the internet and then connecting to the internet. And this means a lot of things to a lot of different people. If you've done your own kind of at-home homebrew IoT projects, you've probably been moving from taking something where you have an Arduino that is connected to something like a water monitoring sensor, and then moved it from having just a data logger to then using something that is connected to the internet and then logging it in the internet so that you can share that data in other places. For other domains of IoT, there's industrial and commercial. So these are people who are using monitoring inside of manufacturing and automation. And then you have consumer and device manufacturers. These are the people like the Nests of the world, who are taking a thermostat, which conventionally was just a simple analog device, and they're adding controls to it that are internet connected, so you can do more smart things. So this is sort of what IoT means to me. And in the context of IoT, what is Google providing in Cloud IoT Core? And so there's a lot of things that you want to do on the internet with your data. And there's a lot of things that you want to do, or there's a lot of limitations that you have on your devices. And so what Cloud IoT Core does is it allows you to connect lots and lots of devices to our cloud infrastructure through a couple of services. I'm not going to talk at great length about this, but right now. But the first thing that you need to understand is that Google Cloud PubSub is the entry point to Google Cloud Infrastructure from Cloud IoT Core. And don't worry, I'm going to give you a little bit of background right now on what all that stuff means. But before I do that,
so
let's
actually,
talk about...
Gus, before we dive into that, can we go back to that slide? So one thing I do want to call out here is that a lot of these are products that kind of exist for data analytics in the cloud, separate from IoT, the IoT use case, right? So this is something where if we look at PubSub, Dataflow, CloudML, these are things that you can all use separately, but Cloud IoT Core kind of bundles all of these together and adds some very specific IoT.
Yep. Yeah. So actually, the IoT specific stuff is really on the left, which is just so there's an IoT. So there's some IoT functionality that is exposed. This is the new stuff, and then all the stuff on the right is the Google Cloud infrastructure. And so Google Cloud infrastructure is basic. It's developer products that are the same or designed in the same way as the infrastructure that Google uses for its own products.
Got it.
And so so which is actually why we think that Google Cloud IoT Core is a compelling product. Google's infrastructure has been well proven in Google's products and in a number of other people who have adopted us. And what we're trying to do with Cloud IoT Core is give developers the security, scalability, performance, and global distribution that you need for your IoT problems. If you've done homebrew IoT before, you probably took a Raspberry Pi and then connected Fermata to it so that you could read sensor data, and then you stored that inside of like a MySQL database that you're kind of hosting somewhere on some managed hosting. This doesn't really scale to 1 million devices. And if you're trying to manufacture, say, 1 million devices, and you want to have credentials baked into all those devices, there's no way you're going to be able to manually provision those. And so what the Google Cloud Infrastructure does is it gives you a lot of capabilities that will allow you to do that automated device provisioning, controlling which devices have access, knowing which devices are out there, and then communication to and from devices. So at the protocol level, we currently support MQTT, and don't get too caught up in this one. MQTT just really means PubSub. It's a special type of PubSub that is very purpose specific for constrained devices. And if you worked in IoT, or if you've done an IoT project before, MQTT probably came up, and that's because it was more or less created as a standard by IBM in the 90s. And it's a binary protocol, so it's really efficient in network usage. Yeah, and it also doesn't use very much power. So it's a natural choice as a protocol for IoT. And if you remember back to like that high level architecture diagram, the first thing that I was talking about was PubSub. And so PubSub is Google's message queue solution. So it allows you to do publish and subscribe operations. And this is a service that automatically scales. It's managed by Google, and so you don't have to worry about allocating the right number of virtual machines and so forth for this. And it's the messages that come in through PubSub are guaranteed delivery of at least once. And so it's when you have these large scale distributed systems, you have to make certain types of trade-offs. Because it's such high throughput and it's globally distributed, the messages only will persist in the server for up to 7 days. And there's also coarse ordering, so you don't necessarily know the order in which the messages come in. And so then what do you do about this? And which is where I want to introduce one more in the last Google Cloud Infrastructure project, and this is Dataflow. And so what Dataflow does is it allows you to take streams of data and then pipe them into other locations. And so the stack that we're talking about here is we've got IoT Core, which takes messages from large numbers of devices, lots of fan-in, and then that goes to PubSub, which is high throughput and regional, and then that typically will go to Dataflow, which you can then use for analytics, machine learning, and so forth.
Right. And so with IoT Core, we're actually getting that MQTT functionality on top of PubSub. Is that correct, or it's kind of like
that is exactly correct? Yep.
Okay,
nice. So it's not exactly a broker. We like to think of it more as a bridge, but yeah. So MQTT. So this what Cloud IoT Core does is it allows you to get to PubSub without having to do all of the without having to have the API infrastructure that's required to use PubSub.
Sure.
In various implementations, you could just directly use PubSub, but there are some limitations that Cloud IoT Core works around on PubSub that are convenient for devices.
Awesome.
And so, okay, so given that stack, so we've got Cloud IoT Core, and then we've got coming into PubSub, and then typically you'll be using Dataflow and solutions. What is provided in Cloud IoT Core? So what are the two things that you need to do when you have these constrained devices and large fleets of them that are going to be interconnected? So you need two things. You need something, so you need the MQTT bridge, which I talked about a little bit earlier, for communicating to and from devices. And then you need a device manager. So this is the identity for how you control which devices can connect to your project, to your cloud projects, and how do those devices connect. And what's important also for the device manager is that you need to understand that registering these devices is something that people are going to want to do in an automated fashion if you're creating large numbers of devices at scale. And so the device manager is what enables that type of functionality for device manufacturers in the commercial area and potentially also in the consumer devices area. Okay, so how does this all come together? How do people build products using these collections of services? And this is the last part of the architecture. So after this, I'll be talking at a lower level about the product. So let's talk about this first pattern. Telemetry analytics. In these kinds of scenarios, you can imagine someone where they have a large number of data aggregators, for example, weather stations, that are located in various areas around the world. And each of these weather stations is recording data that you then want to pipe into some sort of data warehouse somewhere so that you can perform analytics on that and look at trends in that data. And so the way that this works is this is that stack that I was talking about before. You've got Cloud IoT Core, which is your data ingress from all of those cloud connected devices. And then that is going to take that data, put it into PubSub. And then because that data, you want to do analytics on that data, you would then use Dataflow to extract that data from PubSub and then put it into a data warehouse. And so Google's data warehouses are Bigtable and BigQuery. And then you can perform analytics inside of the GUI using Data Lab or Data Studio.
Okay. And one thing I think we are getting a question from a noob in the chat, just kind of to level set on PubSub and Dataflow. And so let me give a crack at it, and Gus, keep me honest. Let me know if I'm off. But pretty much like you said, so we have Cloud IoT Core, that's your ingress, and we have a bridge that leads you into PubSub. So PubSub is pretty much, the TLDR is that it's a global serverless, gosh, a lot of buzzwords, global serverless, but it's really a messaging bus, right? Something where you're able to asynchronously push messages to, and then you can have kind of subscribers pull from that. One of them being Dataflow. And so Dataflow is another serverless thing that allows us to perform transforms, group by keys, what have you, a bunch of primitives, but pretty much transforming your data and then dumping it out into one or many sinks. That could be like a data warehouse or something like that, right? Is that on base?
Yeah, that is right on track there.
Okay, cool. So just wanted a level set for the audience there.
Yep, totally. So yeah, PubSub is really just a message queue, and so you have you've got publishers and you've got subscribers, and you have topics and subscriptions. So you publish to a topic, and then you subscribe to that topic to pull off of that topic.
Okay, got it.
Yep. And so so telemetry analytics, we expect a lot of people to do things like building weather stations or getting, taking their data and then getting it into the cloud from lots of connected devices. And so another pattern that I expect developers to want to explore is device-to-device communication. So in this scenario, you've got something like a room. So we did a demo like this in the spring, where we had a room and we had multiple temperature sensors inside of that room. And as the temperature in the room changed, those 3 temperature sensors would then notice that the temperature was going up. And then if a certain threshold was reached inside of the aggregate temperature, then another device would have a fan turned on. And so this is how you would implement that using Cloud IoT Core, PubSub, and Dataflow. So you in the top here, you've got your first device, and that device is connected to Cloud IoT Core using MQTT. And then you've got a PubSub topic that has all of these temperature data being published to, and then Dataflow is going to take that from, so the PubSub will have sensor data from multiple sensors. And then you can do something special inside of Dataflow where you take a moving average of all those sensors, and then when the threshold of that moving average goes over a certain limit, then you can then you trigger a cloud function, which then uses Cloud IoT Core to change the configuration of another device to actuate a fan. And that's one of the unique features of Dataflow, is that you can have that kind of logic right inside of Dataflow. And so there's one more pattern I want to share, and this is really just a variant on that pattern. This is actually another project that we demonstrated. I believe we demonstrated this one for IL. And so in this example, you have device-to-device communication, and you want to do real-time control of an Android Things device. And in this scenario, you have the same thing that we had before. We had a number of sensors. For example, you could have a photovoltaic sensor that measures how much light there is in a room, so that when the room goes dark, it turns on a light. In this case, so you've got your device with the photo sensor, and that's connected to Cloud IoT Core using MQTT. And then from there, you've got your PubSub topic that you're publishing to, and Dataflow is then going to take the data from that topic. And then Dataflow, instead of triggering a change inside of Cloud IoT Core, what we're going to do is we're going to change a Firebase real-time database. And so Firebase real-time databases are really useful for sharing state amongst a number of clients. And in this case, that Firebase real-time database will say, turn on the state of this light to on. And then you can see that state change in all the places that are accessing that database. For example, if you have an Android app and an Android device and a web page and so forth, all that can have nice shared state made convenient with Firebase. Awesome. And so that's kind of how the architecture works, and so that hopefully that helps you understand a little bit about why it's useful to have all of these products in place when you have your IoT connectivity. And so now I'm going to go one layer.
Hey, so Gus, before we dive into kind of a little more of the low level with Device Manager, we have another question from Nick Davey. So he's asking, do any of these components in these architectures run in the same physical location of the devices, or are they all cloud-based? And I think I know the answer to this, but I'll let you kind of run away with it.
We're talking about the cloud. It's all cloud-based. Yeah. So these pieces are not actually hosted by the user. They're not managed by the user. They're entirely managed by Google. Hopefully that answers the question.
I believe it does.
And it's also worth mentioning that Google in general tends to we tend to use open standards. So if you are interested in hosting certain components of this on your own, in particular, Dataflow is it's like Dataflow v2 is based on Apache Beam. If you want to host your own Dataflow servers and you want to use those in coordination with PubSub, you can. And so a lot of these components are interchangeable with like external open source projects.
Exactly. Yeah. Dataflow is pretty much our managed service for executing Apache Beam pipelines. There are other multiple runners that you can kind of execute these pipelines on, and that means you can run them elsewhere, like you alluded to, Gus. So appreciate that clarification.
Yeah, exactly. No lock-in. Yeah. Okay, so let's talk about the first component, or the first service that's provided by Cloud IoT Core, and this is sort of like how you're going to work with IoT Core in if you're using a project or doing a project where you have where you're going to be using our cloud infrastructure with your constrained devices. So Device Manager is the first thing I want to talk about, and I like to think about Device Manager as the identity provider. If you've done, and the identity provider meaning that like this is the thing that keeps track of which devices are authorized to connect, and also maintains which devices have connected and so forth. So the Device Manager uses a resources module. So we associate all of your devices into this collection called a registry. And so the registry contains devices, and then each of those devices has credentials associated with it and a configuration associated with it. Also of note is that every device registry is associated with a Google Cloud PubSub. I mean, obviously, because PubSub is behind the scenes running a lot of the message ingress. And each of these, and because those resources are associated with a Google Cloud project, this project then is effectively the container for the PubSub instance and your device registry. So before you can put devices into that registry container, you need to be able to have this registry to contain those devices. And so the device manager allows you to create registries, and each of those registries is going to be regional. And so and what that means is that your performance, so your network performance, will be better for devices that are in certain locations because that data collection will be closer. And in general, so as I mentioned before, like you kind of expect yourself to have, so every registry is going to be associated with a single PubSub, and every PubSub typically will be then, putting your data into Dataflow. So you are going to probably just want to have a single registry per project. And then later on, we'll be thinking more about ways that people can intelligently use multiple registries per project. But right now, it's the right way to approach this is just a one-to-one. And so here's the module, or here's the CRUD model for controlling registries. So before you can register devices, you need to be able to produce your registries, and we provide this API so that people can use registries in a variety of ways. In some cases, we expect people to use to manufacture devices and then take credentials, bake them in, and then actually provision those devices at manufacture. In other cases, people will not be delegating provisioning to their manufacturer, and instead will be doing provisioning later in the process. And so this API allows you to do both of those without having to make any compromises. And so going back to what we were talking about before with the resources model, you've got your project, and that project contains device registries that are associated with a single PubSub topic. And then, so then after you have these device registries, you need to be able to put devices into that registry. And so that's what the devices create, read, update, and delete APIs let you do. And if you look at the right of this slide, you can see what happens after you produce a device. So you create a device, and then a response body will come back with all of this great metadata about that device. And that metadata is possible because we know which device has connected at which time. And so we have things like heartbeat, and we have things like the last time a configuration was transmitted to a device inside of device metadata. And which leads to the next piece of device data. And this is configuration. So configurations for devices can exist for every single device in your registry. Additionally, we maintain the last 10 versions of that configuration data. And this is so that you can, and this is because we anticipate people to use configuration data in a lot of different ways. The format of the data is binary. So that means that you can do things like take machine learning models, put it into a configuration, and then transmit it to your devices if you want to update the model just using configuration changes. But it also can just be serialized JSON, which could be something like key value pairs with something like fan speeds for fans that are connected to your device. And configuration changes are sent to the device the first time that your device connects, and anytime that the configuration is changed. In this way, your devices will always be able to say, to stay up to date with the latest configurations that you're controlling using Device Manager.
Awesome. Hey Gus, we do have a question from Yuri. So with regional registries, what's the recommendation for a global population of devices, not limited to one region?
Yep. I don't know exactly. I'm still kind of wrapping my head around some of that stuff, but I believe that the recommendation that I have been giving people has been to use the region that is closest to most of your devices. Okay. Yeah, so because this is going back to that slide I was just talking about, the one-to-one relationship between projects and device registries. So my recommendation right now is just use the registry that's going to be closest to the most of your devices, and then you'll have the lowest latency to your devices from in that way. And
perfect.
And we're still in a limited beta. And during the limited beta, you don't have to select a region yet, really, because we only have US Central 1. will be, I mean, obviously, as like we start scaling out to more users, we're going to have additional regions. But right now, we're just keeping it in just a single region. But because
that makes sense.
This is just sort of like the natural way that that we ended up working with PubSub. Okay, so you have your configurations that can come down to devices. Those configurations can be binary data. They can be serialized JSON. And then there's also metadata associated with those devices. And that metadata, the reason that we're able to have that metadata is that we know which devices have connected and when. And we also know various things about when those devices have acknowledged that they've received data. So in order to know which devices are connecting, we need to have an identity solution. And so we use asymmetric encryption. I don't want to go too deep into the details of which encryptions we support, but we support the most common ones that you would expect for constrained devices. And the device identity, so the asymmetric keys and the asymmetric encryption is used to authenticate the device, and that authentication will have information such as like the device identifier and an expiration for when that credential can no longer be used. We also support storing.
Sorry about that, Gus.
Oh, no.
One thing I did want to ask is I guess previously, before Cloud IoT Core existed, how were people trying to work with IoT in Google Cloud? Were they using service accounts or to manage this identity across all these devices? Or I'm curious, just to kind of show the value prop of what IoT Core is providing.
Sure. So there's a couple of things. So for IoT, we've had a couple of things that existed in the past, and there's a couple of solutions that people are working with right now. One of the solutions that's really common currently is to use PubSub directly from a embedded Linux class device. So you have something that's akin to a Raspberry Pi or a BeagleBone, and that's going to be running full Linux. And then from there you can run Python, and you've got all the conveniences of an operating system, such as like time, and you've got your DHCP stack. So from there you would connect a radio, and then from that radio you would use that embedded Linux class device as a bridge between constrained devices. So you would have something like a private network that's got all these ESP8266s that are connecting to some device bridge that's running on like a private AP, and then that device bridge would then take that sensor data. And so really what we were looking at previously was people doing custom solutions very similar to what our device manager does.
Got it.
And so so at the core of it is identity, and so identity is the magic that allows us to know things like the last time the device connected, and we record things like acknowledgement of when a device received configuration changes. Okay, so the last thing I want to talk about for identity, so because we need to be able to securely connect, because we need to know which device is connected when. We only support TLS, and we only support MQTT version 3.1.1, and we only support QoS1, which is not so. We don't support exactly once delivery, which means that whenever a device receives a configuration update, we just consider it acknowledged, because that configuration update could actually come down to the device twice. And we use the standard ports that you would expect for MQTT. Okay, so that's all I had to talk about with the device manager. So going back to what we talked about before, there's this large architecture where we have the Cloud IoT Core services that allow people to use constrained devices to then connect now to this bridge that is connecting PubSub to those constrained devices. And the last thing that we need to talk about is how does devices talk? So how does your little memory constrained device talk then to that device, to the device bridge? And that's where MQTT comes in. MQTT allows you to do things like send messages to a topic, and then subscribe to messages or to changes on a topic. And so the first thing I want to talk about, because it was the last thing I talked about in the last section, is authentication. So authentication for MQTT is done. It's using username, password, and for our service we don't use the username at all. We just use the password. And the password contains a Java Web Token, or a JWT, and that Java Web Token is signed using the device's private key. And so if you're familiar with asymmetric encryption, the way that it works is like you give your public key away, anyone can read that, and you can't discern the private key given the public key. And then that private key that you securely store is used as something similar to like a password. And so when you authenticate, you connect with a blank username or whatever you'd like to use, and then the password contains the JOT, and the JOT has identity information for the given device and can be verified by the server. And so the JOT tokens expire so that if they're intercepted, they can't be replayed, and also so that they can't be and to protect against brute forcing the decryption. And so the device clock for calculating the expiration time for that JOT token must be within 10 minutes of Google's time. So there's time.google.com that you can use to receive the time that Google thinks it is. And also of note, in a lot of memory constrained devices, you will not have a system clock or a real-time clock. So it's actually convenient to be able to connect that time server to get the latest time. So after you've authenticated, you're going to want to publish things like telemetry data or control information to your PubSub message queue. And so you can only publish to topics that start with devices / your device ID / events. And anything that comes after the events becomes what's referred to as a subtopic. And then that is stored as metadata inside of PubSub. And I'll demonstrate that in just a few minutes. So if you're encountering trouble when you're publishing to a topic and you're not sure why it's not appearing, maybe you're just using the wrong prefix. Just make sure that when you're publishing that you publish using this pattern. And so that's pretty much what it is that's pretty much all there is for publishing. So when all you need to do is just transmit your data right in, and the payload can be pretty much anything that you want it to be. And so the way that we anticipate people to receive data on their devices is just configuration changes. And so the only topic that you can subscribe to is your devices / device identifier / config topic. And this topic will contain all the configuration changes for a given device. And again, like there's device-specific configuration, there's device-specific credentials, and that's really unique when you start thinking about say 1 million devices or millions of devices. And so when do you receive your configuration changes? You receive them whenever you connect. So the first time that you connect, you can get the latest configuration, and then whenever a configuration changes, that topic will receive the device will receive a notification on that topic, indicating that the configuration has changed, and now they can download one. Okay, and so now it's time for me to demonstrate. So I'm just going to go through. So hopefully a lot of this stuff will be familiar to you. And Anthony, is my screen an appropriate size? Can you see it okay?
Yes, sir. Yep.
Okay.
Looks good to me.
Okay, so the first thing I'm going to do is I'm going to use the device manager to create a new device. And mind you, this is like a virtual device because because I don't have physical hardware that I can test this with currently.
And can I just pause? Is that the Cookie Monster behind your terminal there?
Oh no! Yes, it is. Yes, coming through. Yeah, this is my audience right here.
Fantastic.
Okay. But yeah. So first I'm going to register. So I'm going to register a device using the RSA credentials that I've already generated in a previous step. And so what's going to happen is this is going to make an API call to the device manager API that will then register the device inside of the MQTT test reg registry. And that device will have an identifier hello-gcp-meetup. And after you create the device, you will receive back an acknowledgement in the form of a JSON body with the configuration for that given device. And here you can see that we also have this metadata and the credentials for that given device. You'll notice that the credentials have an expiration time of roughly the epoch, I believe, and that indicates that these credentials don't expire. So now that we've created a device, we can go into MQTT, and then from MQTT, I'm going to connect to the MQTT protocol bridge, and then I'm going to transmit some telemetry messages. And that's not the device name. Call it Hello GCP Meetup.
Yes, I believe that was it. Hello-GCP-Meetup.
Okay, so this uses the private key to connect, because that private key is used to encrypt the authentication message. Okay, so when I click enter, it's going to connect to the device bridge, or to the protocol bridge, authenticate, say who it is, and then it's going to start publishing messages. So now it's publishing messages, and it's kind of it happens so fast. But now what I can do is I can use the G Cloud command to pull those messages from the PubSub queue, and this is sort of just kind of acknowledging what was going on.
Oh, awesome!
And looks like I still have some messages that haven't been dequeued, but there they are. So now you can see the Hello GCP Meetup payloads being transmitted, and this is just exercising the platform in kind of an end-to-end manner. And so there you've seen it. That's just, so at a high level, you've got your devices, you register your device. So you create your device registry, and then you insert some devices into that registry, and then you can connect a device, and then that device can send telemetry events. And that's it. So if you're interested in learning more about Cloud IoT Core, we have documentation online at cloud.google.com/IoT Core. And there's we're still in a limited beta, but you're free to sign up, and you'll receive notifications when changes occur. And we're trying to get in as many people as we can as we scale up the product for general availability.
That's awesome. Thanks,
Yeah.
Gus.
Yeah.
We do have a few remaining questions before we let you off the hook here.
Cool.
And so someone is asking, and let me scroll up to the question, really about kind of allowing for devices that have intermittent internet connection to do some type of, and I'm not sure, it's not clear what they would like to do local to the device, but is there some type of SDK to do something on the device with Cloud IoT Core?
So the short version is that it depends, because we don't provide
Okay.
The first thing is that sort of you need to know more about the device. Like, is this a device that's going to be running some sort of, if it's running something like which programming language are you looking for support in, and what kind of functionality you're looking for. So we don't provide something like an operating system in Cloud IoT Core for these kinds of scenarios. For things where you have intermittent connectivity and you can have a device that has the capabilities of an operating system, you would want to probably be looking towards Android things for this kinds of functionality. In Cloud IoT Core, we're actually looking for sort of, it's like the minimum viable product for internet connecting devices that have not been conventionally internet connected. And
No,
so that kind of, yeah.
Let's see. So it doesn't look, I feel like that answers kind of the remaining questions, or all of those were within the category. And again,
No
I
more
think,
questions.
we also have your Twitter handle there, so people can, it's a dangerous thing.
Oh, yeah.
I hope that, a lot of people are, and it does, just based on the chat, a lot of people are really excited about the topic that you've presented today. And so, again, like you said, this is just the beginning of our work with, this product, and it's still in beta. So obviously there are a lot more exciting things to come.
It still is in,
so we appreciate the time,
actually
guys.
like limited beta, because we're still not letting everyone in. But
okay,
yes,
there you go.
Yeah, so it still is pretty early for this product. But yeah, we've already made a lot of progress since the spring, and it's a really exciting time for IoT.
That's awesome. And really, the last thing I'll wrap it up with is one thing that blows, or that I think is really cool about Cloud IoT Core, is that kind of two-way or the bidirectional way that it operates, as far as bringing data from these devices into different platforms to kind of analyze it, but then also giving that device management aspect, right? So being able to push out configurations to other devices based on, kind of Cloud IoT Core bridging these respective devices. So, I mean, man, I am still a noob, a rookie to IoT Core, but I feel a little smarter today after listening to you. So
oh, thank you.
Appreciate it. Awesome. And so stay tuned for the rest of our GCP online meetups. We try to have these weekly, and thanks again for joining.
All right. Thanks, everyone.
Thanks, Gus.